Okay, so now today's class will discuss about this what Dalton's law of partial pressure. So before this class, we had in the previous class we have discussed gas laws. Okay, so what is a Dalton's law of partial pressure? All of you can see what is the meaning of this. What is this law? So basically, what is Dalton's law? What is this law? You can see there's a two flask. The flask A, in which one gas is there. Suppose gas A, and flask B, there's another gas. Even a gas is mentioned over here. So in flask A, there is a helium gas, and flask B, there is a hydrogen gas. Okay. And you can see if there is a one gas, that is a pure gas. Suppose there is only helium, that is only one gas, pure gas is there. So whatever the pressure will be there, that is the pressure of helium gas. Similarly, in other flasks, the pressure of the hydrogen gas. Okay. Whatever their pressure, there's a different pressure. Okay. And this is this knob which is closed, so they are not mixing to each other. Okay, so what will happen if this knob will be open? You can see in the next slide. So when the knob will open, and this is actually it's all the gases going from this is the heavier part. So if all the gases are mixing in one flask, okay, suppose in B flask the both gases are there. Now there is not only hydrogen, there is a helium plus hydrogen gas. Now in this flask the pressure which one will be exerted, that will be the pressure of both gases, not only one gas. So if any gas is in pure form, that the pressure will be exerted from that gas only. But if there is a mixture of two or more gases, then the total pressure which one will be exerted, that will be the mixture of, that will be the sum of the pressure of both gases. Okay. So this total pressure is equal to the pressure of the helium plus pressure of the hydrogen, and which is equal to 760 mmHg. So this is the 760 is the total pressure, and these are the individual pressure. So in a mixture, the individual pressure of each gas is called partial pressure of that gas. So this is the Dalton's law. So what Dalton's law state that the total pressure exerted in a mixture is equal to the sum of the individual pressure of each gas, or we can say the total pressure exerted in a mixture is equal to the sum of the partial pressure of each gas. So now this is a definition. The total pressure exerted by the mixture of non-reacting gases. There's a one condition: the gases should not be react with each other. Suppose if you are taking two gas which may react with each other, then this law will be not applied. So the total pressure exerted by the mixture in which the gases should be non-reactive is equal to the sum of the partial pressure of individual gas or each gas. Or we can say the P total, that is total pressure, is equal to the P1 plus P2 plus P3 at a given temperature and volume. So what the two conditions should be constant? There is a temperature and volume. Okay. And what is P1? What is P2? These are the partial pressure of gas 1, gas 2, gas 3. So P1, P2, P3 are the partial pressure of individual gas. So this is Dalton's law. Okay, you can see one more example. Okay. This is the application of Dalton's law. What is the application of Dalton's law? Okay. The gases which are collected over the water, that means we can say the gas which is collected over the water by downward displacement, or we can say downward displacement of water. Okay. Then in that case, the pressure of dry gas will be equal to the total pressure minus aqueous tension. I will explain. I will just write it and I will show you once again. Okay, you can see over there. So the pressure of the dry gas is equal to the total pressure exerted minus aqueous tension. Aqueous tension means the pressure of uh, vapor pressure we can say, or water gas pressure. Okay, so what is the application, or what are the application of Dalton's law of partial pressure? First application, the partial pressure in terms of mole fraction means P1 is the partial pressure. So what is the application of Dalton's theory? The Dalton's partial pressure theory, the first application, the partial pressure of any gas can be calculated using multiply of the total pressure with mole fraction of that gas. Means P1, which is the partial pressure of gas 1, which is equal to the mole fraction of that gas into total pressure. Okay. So this is first application you can say. Okay, better I can write and I will explain again. Okay, so what I told you, now you tell me. What is Dalton's law of partial pressure? What you can say? Anybody? Now you tell.
Individual pressure of non-reactive gases in a mixture.
Correct. Okay. So just we have discussed Dalton's law of partial pressure. So what the theory and what the explanation we have just studied. Okay. So it states that, again, I'm revising. So what is this theory? Suppose this is one container, okay, in which the gas A is there. Suppose any gas is there, A, gas A. And this is the second container in which the another gas is there, okay. And they are connected with each other, but this knob is closed. So now the what the pressure exerted over here, that will be the pressure of A, and what the total pressure exerted, that is the pressure of B. So this is the pure pressure, which is a pressure of gas A, and this is a pressure of gas B. But suppose when the knob is, okay, I just show the color, different color. Okay, this is the B and this is A. Okay, so there is only this A gas particles are present and this is closed. Suppose if we'll open it, what will happen? So it will, there's a open area is there. Okay, so when it will be open, you can see what will happen. All of you know this thing also. So when it will be open, so the gases will start moving here and there till equilibrium not achieved. So some gas of A will be here, and similarly the B gas particle will be coming over here. So there's a what now there is a no pressure pure gas. There is a mixture of gas. Now in everywhere the gases are present. Okay. So now in this case the P total. Now what the total pressure exerted now? This will be the sum of the pressure of gas A plus pressure of gas B. Okay, so this is Dalton's theory. So what Dalton's theory states that the total pressure exerted in a mixture is equal to the sum of the individual pressure of gas, or we can say sum of the partial pressure of individual gas. So this is the total pressure, and what is PA now? Now this PA is the partial pressure of gas A, partial pressure of gas A. Similarly, PV is the partial pressure of gas B. So Dalton's law states that the total pressure exerted in a mixture is equal to the sum of the partial pressure of each gas. Okay, if suppose we are taking three gases, then PA plus PB plus PC and so on. Okay, so we have just discussed this thing also. Now, and what is partial pressure? Partial pressure is what? Partial pressure is the pressure of each gas in a mixture. So what are the application? Acha, before application, just we'll discuss one thing more also. Just a minute. Suppose all of you know PV is equal to what? nRT. Okay. And this Dalton's law theory applied at constant temperature and volume, because in this container the volume is constant. Suppose the container's total volume is 1 liter, that means 1 liter, and the temperature, suppose a room temperature, so T will be constant. Okay, now all of you know PV is equal to nRT. Here volume is constant, T is constant, and R already constant. So what are the two variable parameters here? Because the gases are different, so might be number of moles will be different. Suppose if one is A, P, PA, so sorry. Okay. If suppose it is PA, so it is Na. Okay. So what we can write, or if suppose, so what we can write, Pa is equal to Na RT by V. Similarly, if suppose the gas B, so what we can write, NB RT by V. Okay. So now what is the total pressure exerted? The total pressure exerted is what? P total, which is equal to, just I have written, PA plus PB. So instead of PA, what you can write? Na
Na plus NB RT by V.
RT by V will be common, so simply we can write Na plus NB RT by V. So we can write in this way also. So the P total of any mixture of gas is equal to partial sum of the partial pressure, or we can say it is equal to Na plus NB RT by V. R and T and V constant. Okay. So this is the actually complete Dalton's law of partial pressure. Okay. Now I just told you what are the applications. So what is the first application of Dalton's law of theory? The first application, this, the partial pressure of any gas, the partial pressure of any gas, that particular gas, partial pressure of a gas, or we can say a gas, can be calculated using mole fraction. Okay, so this is the first application, means we can calculate the partial pressure of gas. Okay, and this is formula is what the formula is coming, that means the, suppose ki I am telling Pa, which is equal to chi A into P total. Okay, so partial pressure of any gas can be calculated using mole fraction multiplied by total pressure. Okay, so this can be calculated. Similarly, PB chi B P total. Okay, and how it comes, if you want to see, you can see. I can go to the next page. What I wrote over here, P total. Okay, which is equal to Na plus Nb RT by V. Just I wrote this one. Hold कर लो, sorry. ठीक है. If I write कि PA, तो PA is equal to, अच्छा, just I've written over chi A. Okay, chi A into P total. ठीक है. तो chi A कैसे, chi A का मतलब क्या होगा? What is the meaning of chi A?
Na upon Na plus NB.
Ma'am, number of moles of A
ठीक है.
upon total number of moles.
total moles.
ठीक है. एंड इसको हम डिराइव कर सकते हैं. नाउ द सेकेंड एप्लीकेशन, जस्ट आई राइट, सेकेंड एप्लीकेशन है कि द प्रेशर ऑफ एनी ड्राई गैस कैन बी calculated using aqueous tension. And which type of pressure of dry gas can be calculated using aqueous tension, which is collected over downward displacement of water. What is the meaning of this? You have read in class 10th even also. Just I draw that one. Ki, this is a container, suppose flask. Okay. And this is a thistle funnel in which sulfuric acids are there. And this thistle funnel, H2SO4 is there. Okay. And here you are taking the zinc granules. So what happens? The H2 gas release. Okay. And this H2 gas is collected. I'm just drawing very rough diagram, very poor diagram. So now this is collected in trough. Okay, there was a one trough in which the gas is collected over there. Okay, water is there and the hydrogen gas is bubble comes over here and which is collected over here. So there is a hydrogen gas is collected over here. Okay. But this hydrogen gas, so the pressure of hydrogen gas exerted over here, but beside hydrogen gas, the water vapor also collected over there because there's an exothermic reaction. Some water vapor also evaporated and collected over there. So what we can say, there is a one gas or two gases are there. Two gases are there. So this is the pressure of dry gas, but we have to calculate only the pressure of hydrogen gas. But when we measure the pressure, जब हम pressure यहाँ measure करेंगे, तो that we are getting the total pressure. So this total pressure is equal to the pressure of hydrogen gas, that is the pressure of dry gas plus pressure of water, or we can say that is called aqueous tension. Okay. So now when we have to calculate the pressure of hydrogen gas or any pressure of dry gas, that can be calculated by using this, yani P total minus aqueous tension. Okay. So pressure of any dry gas can be calculated using total pressure minus aqueous tension. So these are the application of what? Dalton's law of partial pressure theory. Okay. क्लियर है सबको? Is
मैम
it
एक
clear?
डाउट।
बोलो.
मैम अगर दो गैसेस एक कंटेनर के अंदर है
Hmm.
और वो रिएक्ट कर जाए तो मैम फिर भी डाल्टन्स लॉ ऑफ पार्शियल प्रेशर
No,
लगाएंगे?
then it will not apply. Suppose you are taking a container in which hydrogen and oxygen gases are there. Okay. But if suppose condition is in that way they can react, then the partial pressure will not apply. The gases should not be react with each other. The gases should be non-reacting gases. Okay. Suppose
Okay.
here the hydrogen gas is collected and water gas is also collected. They are not reacting. Okay. Or suppose here the nitrogen gas and some helium gas like this. The scuba diver leke jaate hain na, the scuba diver, they carry the oxygen cylinder in which the helium gas is also present over there. ठीक है, तो वहां पे भी अप्लाई हो सकता है. Understood?
Yes, ma'am.
Ma'am, what are the factors in which aqueous tension depends?
What is the?
Ma'am, does aqueous tension depends on any factor or it
Okay,
is an
yeah, aqueous tension is the tension of aqueous, means the pressure of water vapor, and aqueous tension value is a fixed value because this aqueous tension value depends on temperature. Yes, the aqueous tension value, suppose water का aqueous tension value room temperature पे क्या होगा, that we take the standard value. Okay, so that value is fixed. Suppose it is 20 mm of Hg at room temperature, so this value is fixed. But if suppose temperature will be changed, then value, but it is fixed value at a given temperature. And this Dalton's theory always occur at a given temperature. The T is constant and volume is also constant. So aqueous tension value will be fixed. Theoretically, we take only at room temperature, what is this value? Understood?
yes, ma'am.
Okay.